Okay, so just to continue from the last video, all right, we have the understanding of the voltage divider rule. How about the current flow? All right, so the important rule to remember is for series circuits, okay, for series circuit, the current, all right, the current I will be the same, okay, for all the components that are connected in series. Okay, so as long as there is no split in the current and the same current flows through one component and the other, then we say that those two components are in series. For example, the current that comes out of the supply goes through R1, comes out of R1, and then that same current goes into R2 and comes out of R2. Okay, there is no point where there is a split or a branch where some current goes in another direction. Alright, so we say that the same current I is flowing through both R1 and R2. Alright, so in this case, okay, we say that since both R1 and R2 are in series, to calculate the total resistance for series components, we just add up all those components in series. So it will be R1 plus R2. Again, this is only for series. So in this case, it will be 56 plus 180, which is 236. Okay, now once I know the total resistance, alright, okay, I can effectively redraw my circuit. Okay, I can effectively redraw my circuit to a single supply, okay, and a single resistance, okay, which is 236 ohm. Okay, so with this, I can calculate that I to be V by R. So this is Ohm's law. So Ohm's law says that the current through a resistor is directly proportional to the voltage across it. So in this case, the current is the total voltage over total resistance, okay, which is 5 over 236, okay, which is 21.19 milliampere. Alright, now since we said that the current is the same for series components, I can actually calculate the current based on VR1 and VR2 as well. Okay, so if I were to calculate the current, okay, coming back here, okay, if I were to calculate the current here and say that, for example, okay, let me separate this out. So since I know the voltage across R1 is 1.186, I can say 1.186 over 56 is also going to be 21.19 milliampere. Or if I go for R2, okay, the voltage is 3.814 divided by 180, I will also get 21.19 milliampere. Okay, so you can calculate the current based on Ohm's law, which is the voltage across the resistor divided by the resistance value. That will give you the current. Okay, so this is a series circuit, so the current through R1 and R2 is the same. Okay, in this example, what I have done is I have calculated the total resistance, and so I can simplify and redraw the circuit as a single voltage source and single resistance, and then calculate the current based on applying Ohm's law to this new simplified circuit. Okay, so I hope this gives you a good understanding of Ohm's law, alright, and how we can apply Ohm's law to calculate for the current, okay, or voltage or resistance. Alright, so basically Ohm's law is an equation that relates voltage, current and resistance, and depending on what is the unknown parameter you want to find, you can apply Ohm's law and solve it. Alright, so thank you for watching. I'll see you in my next video. Bye.